When you're calculating perimeters, there's just a couple of things to keep in mind. The perimeter is the length around the outside edge of a shape. So some shapes that we see might have other lines on the inside of them, but the perimeter is really just the length all the way around the outside edge, ignoring any lines inside. The perimeter is measured in linear units. Now, what does linear mean? Well, this word line inside the word linear reminds you that it's just the length of the lines on the shape. Now, lines can be curved, so even on something like a circle, you can find the perimeter in linear units, meaning just a curvy line in this case. Now, the units you're mostly going to see are kilometres, metres, centimetres, and millimetres, and you need to be able to know how to make the conversions between these. Now, you'll notice that there are 10 millimetres in a centimetre, there are 100 centimetres in a metre, and 1,000 metres in a kilometre. These are things you need to commit to memory. Some people get confused when they're converting between these things though. What I've written up here, multiply by 1,000 and divide by 1,000, tells you how to get from one unit to another. So, for example, if we have 6.2 kilometres and we want to know how many metres that is, it means we're going from kilometres to metres. Now think how far a kilometre is. It takes you a while just to run 6 kilometres. There's a lot of metres in there. That reminds you straight away, oh, I want a really big number. There's going to be a lot of metres in that. That reminds you that you need to multiply by 1,000, not divide. So don't memorise whether to multiply or divide with these arrows. Just think about it. It makes a lot of logical common sense. Now, to multiply a number by 1,000, the easiest way to do it is to actually just move the decimal point. So let's just do this over here. If I have 6.2 and I make it 1,000 times bigger, I need to move the decimal point, not 1, not 2, but 3 jumps to the right, and it will finish here. Now, there was nothing to jump over, so I need to just add some zeros, and that gives me 6,200. Point nothing. The decimal ends up at the end there. So that gives me my answer. When you've made your conversion, always just have a look at it and see if it kind of makes sense. Here we're going from millimetres to metres. Now, to get from millimetres to metres, we have to make 2 jumps. We need to divide by 10, but then we need to divide by 100. Can we do both those things at the same time? Absolutely. Dividing by 10 just means move the decimal 1 place, because 10 has 1 0. Dividing by 100 means move the decimal 2 more places. So altogether we need to move it 3 places. Now, which way are we going to move it? Well, 47 millimetres, think about how big that is. There's 47 millimetres in there. Is there going to be many metres in that? No, it's a lot less than 1, isn't it? It's much smaller than an actual metre. So that tells you that you're definitely making the number smaller. So write down the number that you have to start with, 47. Where's its decimal? At the end. This is 47, point nothing. Now, to make it 1,000 times smaller, we need to move the decimal this way, not 4.7 or 0.47, but 0.047. And the decimal ends up way over there with another 0. Now, you can put a 0 before the decimal point if you like, and then 1 after, and then your 4 and your 7, and you're done. This bottom conversion makes us take 3 steps. 8 kilometres is how many millimetres? The first thing you should be thinking is, oh, a lot. Okay, I'm going to need to make this a really much, much bigger number. And that tells you that you're going to be moving the decimal this way and adding zeros to the number. So what do? Well, to get from kilometres to millimetres, we have to times by 1,000, times by 100, and times by 10. So we need to multiply by 1, 2, 3, 4, 5, 6, a number of 1 with 6 zeros. That's 1,000,000. The other way to think of it is move the decimal point 6 places to the right. Now, a quick, easy way to do it is to say I've got 8. If I multiply that by 1,000,000, I'll have 8,000,000. And you can pretty much just write that number straight down, and 8 with its 6 zeros. Now, the only other things that are going to trick you a little bit potentially in calculating perimeters is that sometimes you're not given all of the lengths. So, for example, in this drawing, we've got right angles in every corner, but here we know this is 20 metres and this is 10, but we don't know this length here. Now, it makes sense that those two would add up to be the same width of the entire picture. So that means this one must be 10 because 10 plus 10 will give me 20. Similarly, I don't know this length, but I do know this one is 8 and the total height of the picture is 17. So 8 plus 9 gives me 17. Now I know all of the lengths, I can go ahead and add them up. It makes sense to circle your starting point so that you, as you line them up, 17, 20, 9, 10, 8 and 10, you can make sure that you've got all of the lengths in there and you didn't miss any of them out. Add them up and see what you get. Now the only other tricks that you might come across is shapes where you don't know how long something is, but it's got these symbols on it. Now, two symbols, 2 dashes and 2 dashes, that means that those 2 lengths there are the same length. Sometimes they'll just put 1 dash, so you might have a picture like this, a square, with dashes on all sides, and they might just say this is 4 centimetres, find the perimeter. So you need to say, well, if they've all got 1 dash, they must all be the same length, so I need 4 fours, which is 16. Down here, if you're asked for the perimeter of this shape, x is an unknown and so is y, but you can still come up with an algebraic expression for the perimeter. If this is x, this must also be x, so x plus x is 2x, and then we need to add y. Now 2x and y can't really be added except to say we have 2x plus y, and that's as good as it gets. That's a perfectly good expression for the perimeter of this triangle. So there you have it, calculating perimeters. Add up your lengths carefully, make sure you convert your units carefully, and look out for tricks like dashes on lines or missing intervals.